Tens of millions of red crabs crawling their way to the ocean as part of an annual migration on Christmas Island, Australia.
October 2025. The ground moves red. 100 million crimson crabs flood Christmas Island like a living tide. Claws clicking, shells glinting, the jungle floor alive again. But rewind just 7 years, and this same island was a graveyard.
These small critters are embarking on a big move. Nearly 200 million red crabs are making their annual migration back to the ocean, crossing Christmas Island.
An invasion of acid-spraying yellow crazy ants wiped out over 40 million red crabs, turning paradise into a chemical war zone. In desperation, scientists made a decision that sounded insane. They released millions of tiny insect assassins to fight the invaders. What happened next defied every prediction and rewrote the rules of saving ecosystems. But to understand how we got here, how did paradise become hell on Earth? When paradise turned into an acid war zone. Christmas Island's nightmare began not with a roar, but with a whisper. Tiny yellow invaders that arrived in silence and conquered in chaos. Imagine a lush green island, only 52 square miles across, floating like a secret jewel in the Indian Ocean, about 135 kilometers south of Java. Every year, millions of land crabs march from the rainforest to the sea, painting roads and cliffs in red, a ritual that defines the island's heartbeat. Until something microscopic rewrote the story. Between 1915 and 1934, a stowaway hitched a ride in a cargo shipment, the yellow crazy ant. For decades, it stayed invisible, scattered in harmless pockets. But by the 1990s, that quiet invasion exploded. The ants began forming supercolonies, massive underground empires stretching across a third of the island. 2,000 ants per square meter. Imagine standing on a living carpet that moves beneath your feet. An army of millions packed into 1,850 acres, larger than Monaco. And they didn't just take over, they built a war machine. Their weapon? Formic acid. It sounds benign until you see what it does. They spray it straight into their victims' eyes and joints. 1 hit blinds, 2 paralyze. Within 24 hours, 40 million red crabs were blinded, suffocated, and dying in burrows filled with toxic vapor. The rainforest reeked of rot, garbage sweet and chemical sharp. Forest floors that once clicked with crab claws fell silent. When the crabs died, the island began to decompose. Those crabs weren't just decoration, they were the cleanup crew, clearing up to 87% of the forest's leaf litter every year. Without them, debris piled high. Rotting leaves fueled invasive snails, stinging trees, and mold that acidified the soil. The ants farmed scale insects for sugar, bleeding sap from trees until canopies yellowed and bird populations crashed. The ecosystem didn't just collapse, it was rewritten. And through it all, the ants moved with eerie precision. No queen's orders, no chaos, just one shared instinct: expand. They were a living algorithm of destruction. So how do you fight an enemy that outnumbers you 2,000 to 1, sprays acid, and controls an underground empire? Scientists tried everything: traps, fire, poison. In 2002, they deployed chemical baits across hectares of jungle. 99% of the ants vanished. For a moment, the island exhaled. But the victory didn't last. The survivors regrouped, rebuilt, and returned stronger. Every counterattack seemed to feed the problem. It was like fighting a ghost made of sugar and acid. Researchers began to realize they weren't fighting insects. They were fighting a system built to adapt, endure, and outlast annihilation. Then, in the middle of that despair, someone noticed something strange. Buried beneath the chaos, the supercolonies had a single, invisible vulnerability. A parasite already living among them, one that might just destroy their empire from within. Scientists tried poison, lots of it. But the ants had a secret ally, and it was hiding in plain sight. What was it? And could it really turn the tide of an acid war? The hidden enemy, a symbiosis built on sugar. The real power behind the ant army wasn't the ants, it was their sugar supply. Hidden in the Christmas Island canopy lived another invader few ever noticed, the yellow lac scale insect, Tachardina aurantiaca. To the naked eye, it was harmless, a pinhead-sized parasite sucking sap from trees. But together, these scales and the yellow crazy ants built a relationship that rewrote the island's ecology. Here's the twisted brilliance of it. Scale insects feed on tree sap, then excrete a sugary liquid called honeydew. The ants go wild for it. In exchange for that sweet drip, they protect the scales, clean them, and even move them to new feeding sites. It wasn't a random nature, it was agriculture. The ants were farmers, and the forest was their sugar plantation. This partnership created a devastating feedback loop. More scales meant more honeydew meant more ants meant more protection for the scales. Within years, ant colonies exploded into super colonies that wiped out millions of red crabs. It wasn't just survival, it was empire building powered by sugar. By the early 2000s, scientists on the island were desperate. In 2002, they went nuclear poison. They deployed a bait called Antoff, laced with 0.1% fipronil, across the jungle floor. It worked, for a while. In 2009, they scaled up, dropping bait from helicopters across nearly 800 hectares. 99% of the ants vanished. For a moment, Christmas Island breathed again. Then the ants returned. The poison had killed the soldiers, but not their supply chain. The scales survived, hidden deep in bark and sap, quietly rebuilding. Once the honeydew started flowing again, so did the ants. It was like taking down a cartel but leaving the cocaine fields untouched. That's when the scientists realized they were repeating Australia's oldest mistake. In 1935, cane farmers imported 101 cane toads from Hawaii to eat beetles. The toads didn't touch the pests. Instead, they spread across 1.2 million square kilometers, poisoning predators from crocodiles to dingoes. A classic case of good intentions turned ecological horror. On Christmas Island, that lesson hit hard. Poison could kill ants, but not the system that fed them. The problem wasn't the soldiers, it was the kitchen. So scientists flipped the strategy. Instead of chemical warfare, they would starve the enemy, cut off the sugar, and the empire collapses. But how do you destroy billions of scale insects without torching the forest? The 2mm assassin, engineering a cascade collapse. After 7 years of painstaking research, scientists found their weapon. Tachardina ephagus somervilli, a Malaysian micro-wasp measuring just 2mm long. You could fit hundreds of them on a coin, yet this tiny insect was about to rewrite the fate of Christmas Island. At the front of this audacious plan were Dr. Peter Green and Dr. Tanya Detto from La Trobe University, working hand in hand with Parks Australia. Their mission sounded simple, but came with almost impossible stakes. They needed a killer that would only attack one target, the yellow lac scale insect fueling the island's crazy ant empire. If the wasp harmed anything else, the cure could become another catastrophe. So they tested and tested again. In sterile quarantine labs, 8 closely related scale insect species were exposed to the wasp. Not one was harmed. Not one egg was laid outside its target host. That's when Dr. Green called it the most thoroughly researched biological control project in Australian history. Every box ticked, every risk modelled, every generation observed under a microscope. For once, science wasn't gambling, it was calculating. Now, picture this little wasp's life cycle. It begins when a female finds an adult female scale insect, locks onto it like a drone strike, and pierces its shell with a needle-like ovipositor. She injects up to 8 eggs inside, sealing the host's fate. When those larvae hatch, they eat the scale from the inside out, quietly, efficiently, leaving only a hollow husk behind. Then they emerge, fully formed assassins, ready to do it all over again. It's brutal biology, but precisely what the island needed. And here's where it gets almost mathematical. The yellow lac scales can reproduce 3 or 4 times a year, but these wasps? They cycle through 12 to 15 generations in that same time. A 4-to-1 reproductive advantage means the wasps can outbreed their prey exponentially. Each female parasitizes more than 150 scales in her short life. Multiply that by millions, and you get what scientists call a cascade collapse. Once the scales vanish, the ants lose their sugar supply. No sugar means no supercolony. No supercolony means the crabs can finally crawl home. It started small. In December 2016, just 300 founding wasps were imported from Malaysia and reared in custom-built enclosures on Christmas Island. The team fed them, bred them, and waited until their numbers swelled into the thousands. Then came the release. 2017. 18,000 wasps were unleashed across 4 key battlegrounds: Grantswell, Blowholes, Margaret Knoll, and circuit tracks. Tiny black specks drifting through the air, landing on leaves, vanishing into the forest. No sound, no splash, just silence before a storm. The strategy was layered like a chess game. First, the wasps kill the scales. Then the scales disappear, cutting off the ants' food supply. The ant colonies collapse, red crabs reclaim the forest floor, and slowly the ecosystem rebuilds. This wasn't predator versus prey, it was dismantling an entire mutualism network, a sugar economy built on exploitation. They weren't just killing insects, they were rewiring nature itself. But as word of the operation spread, one chilling question lingered. What if they got it wrong? What if these wasps went rogue and attacked the wrong species? What if they didn't stop? Or worse, couldn't be stopped? As the wasps spread silently through the canopy, the scientists held their breath. Would this be salvation or the beginning of another ecological catastrophe? The invisible war. When nature fights back, within 24 months, the results started coming in, and they were nothing short of extraordinary. At the first monitoring sites, scientists counted around 700 yellow crazy ants before the wasps were released. 2 years later, they found just 10. Not 10 nests, 10 ants. It was like watching an empire crumble in real time. But here's the twist that stunned everyone. The wasps weren't just surviving, they were spreading. Field teams discovered them as far as 1.6 kilometers from the release sites, gliding through the forest canopy under their own power. They were breeding, hunting, and thriving. No human help, no extra releases. For the first time, a biological control wasn't just working, it was self-sustaining. Slowly, the cascade began. As the wasps wiped out the scale insects, the honeydew supply vanished. The ants, suddenly cut off from their sugar empire, started collapsing in waves. Starved and scattered, their once coordinated supercolonies fell apart. Territories that had been ruled by millions of frenzied workers turned quiet. And beneath the jungle leaf litter, something even wilder started happening. The ecosystem began breathing again, while Christmas Island scientists watched their 2mm allies rewrite the rules of conservation. Another battle was playing out across the Pacific. Over on Johnston Atoll, a 1 square mile coral outpost used as a military site, yellow crazy ants had staged their own invasion. Their acid sprays blinded seabirds, melted chicks' feathers, and burnt away entire nesting grounds. Red-tailed tropic bird colonies were nearly wiped out. Over 70 acres of breeding habitat were lost, and chicks that survived often hatched with beak deformities caused by ant venom. It was the same invader, the same chaos, but a very different strategy. Johnston's answer was brute force. Between 2010 and 2020, teams of scientists, soldiers, and volunteers clocked over 130,000 field hours tracking, baiting, and killing ants one nest at a time. Every grain of soil was turned, every inch of the atoll combed. By December 2020, they brought in 2 ant-sniffing dogs, Guinness and Solo, to confirm the final sweep. Together, they covered 118 miles of search grid. 0 ants detected. It became the first successful eradication of yellow crazy ants on a large US territory. A genuine miracle, but one built on sheer manpower. And that's where the contrast hits. Johnston Atoll was 1 square mile. Christmas Island, 52. The idea of scaling that kind of brute force mission up was a logistical fantasy. Johnston's approach worked, but only because of its size. Christmas Island's solution, by contrast, was elegant, self-replicating, and relentless. Instead of burning through money and labor, scientists let the wasps handle the war. By 2020 and 2021, aerial surveys and forest floor counts showed clear trends. Ant activity in wasp release zones had dropped dramatically. Tree canopies, once coated in sticky honeydew, were clean again. The sound of rustling crabs, absent for years, was starting to echo faintly through the forest. But the real test wasn't just about numbers, it was about resurrection. Could those 40 million red crabs that once painted the island in motion ever return? Could nature really rebuild itself after being chemically scorched and ecologically gutted? What happened next is what scientists now call an ecological resurrection, and the numbers are staggering. What do you think came crawling back from the dead? The resurrection, 100 million strong and rising. By 2022, the silence on Christmas Island finally broke. After years of lifeless forest floors, cameras caught the first major red crab migration in nearly a decade. Scientists described it like seeing blood return to a pulse. Streams of scarlet lava poured down the cliffs, across roads, and into the sea, as if the island itself was exhaling after a long, toxic coma. Locals stood on bridges and rooftops just to watch it happen. One ranger said, "It was like the island was breathing again." And in a way, it was. Fast forward 2 years, and the numbers are jaw-dropping. By 2024, the red crab population had more than doubled, from about 50 million to over 100 million adults. Just imagine that. 100 million creatures moving as one, an army of living jewels covering roads, rocks, and even airstrips. Every November, roads are now closed, warning signs flash red, and workers erect temporary crab bridges so the migration can pass undisturbed. It's part science experiment, part cultural holiday. Residents cheer. Tourists book flights just to witness it. And the best part? It's no longer rare, it's annual again. This year, October 2025, the numbers are even more surreal. Park rangers estimate nearly 200 million crabs in total, counting the young ones under 4 centimeters. About half of them, roughly 100 million adults, are now part of the full migration, almost matching pre-invasion levels. Every rock seems to move, every forest path glows red. The spectacle is hypnotic. From drone footage, the crabs look like a living river that splits highways and bleeds into the ocean. When they reach the coast, the ground itself seems to shimmer as they spawn millions of eggs into the surf. But the true miracle isn't just what you can see, it's what's happening beneath the surface. With the crabs back, the island's ecology is flipping back to its natural order. Leaf litter, which had piled up for years when the ants ruled, is finally being cleared again. The crabs churn through it like tiny bulldozers, processing dead vegetation, aerating soil, and giving native seedlings space to grow. Ecologists call them ecosystem engineers, and they mean it. The average stretch of forest now holds 1.4 to 1.6 crab burrows per square meter, tiny natural compost pits that renew themselves every 5 years. And their waste, shells, and discarded claws, They're the island's best fertilizer. The chain reaction doesn't stop there. With the jungle floor cleaned up, native plants are thriving again, and invasive species are declining. Abbott's booby, an endangered seabird that breeds only on Christmas Island, has seen its nesting trees rebound in number and stability. Even the island's other crab dynasties are benefiting. The robber crab, or coconut crab, the world's largest terrestrial arthropod, has surged back into prominence. These giants can weigh over 4 kilos, stretch a leg span longer than your arm, and crush coconuts with claws that deliver a bite force of 3,300 newtons. They can live more than 50 years. Picture a creature that strong, roaming freely again under restored canopies. And then there's the blue crab, Tuercayana celeste, a species found nowhere else on Earth, discovered as recently as 2012. Its electric blue shell has started to flash again in the tidal pools and mangroves. Together, these comebacks aren't just survival stories. They're proof that an entire ecosystem can heal itself when balance is restored. Of course, it hasn't all been smooth. In 2024, an extremely dry season slowed down the migration for a short time. This showed scientists that even though this ecosystem is strong, it is still fragile. But the fact that the crabs came back stronger the next year shows something powerful. The system now has a heartbeat again. So, is this a complete victory? Did the wasps really solve everything? Well, not quite. The war isn't over, and the lessons from this tiny island are now reshaping how the world plans to fight invasive species everywhere. But what happens when those same biological weapons start rewriting the rules of nature itself? The ongoing battle. Lessons for a planet under siege. Christmas Island's success isn't the end of the story. It's a blueprint for an escalating global crisis. Because even now, yellow crazy ants are still there. Their numbers have fallen, their grip loosened, but they're not gone. What exists today is a fragile balance, a truce held together by one of the tiniest soldiers on Earth, a wasp so small it fits on the tip of a pen. These wasps don't kill the ants directly. They target the ants' secret weapon, the scale insects that produce the sugary honeydew fueling their empire. No scales, no sugar, no super colony. This approach changed everything. It's not about wiping out a species anymore, it's about breaking the alliance that lets an invasion thrive. Scientists call it ecological network disruption. On Christmas Island, it looks like a balance, but in places like Queensland, Australia, it's still war. There, yellow crazy ants are spreading fast across rainforests and cane fields. The government's $61 million counterstrike now uses drones to map nests and even DNA analysis to track colonies. In Hawaii and across the Pacific, the same ants threaten native birds and entire ecosystems. That's why researchers are studying the Christmas Island playbook, hoping to replicate its success without repeating old mistakes. Because this time, patience won. 7 years of testing proved the wasp's safety. Precision targeting avoided collateral damage. Instead of killing the invader, scientists dismantled its support system. It's the opposite of what happened with cane toads. Those were rushed, reckless, and catastrophic. This new wave of biocontrol isn't about domination. It's about equilibrium, restoring the natural checks that invasive species erase. This tiny wasp rewrote the rules. But what does that mean for the future? Standing on Christmas Island today, watching millions of red crabs march to the sea, you're witnessing something rare. Could this be the start of a new era where nature fights back on its own terms? And now, as millions of red crabs march once again across Christmas Island, the cycle feels almost poetic. The forest breathes, the ground moves, and the island that once looked doomed is alive again. But here's the twist. Scientists say the yellow crazy ants are still lurking, waiting for their chance. So what happens if nature's new balance tips again? Could the island face another hidden war?